Welcome to Larry Talks on the International Space Station Cinematic Virtual Reality Walk.
We are so excited to have you here today. We are, as of right now, officially announcing our project, the ISS Experience. It's a partnership between Felix and Paul Studios and Time. We're going to tell you all about it. There's a lot of exciting news that we have to share for the first time here. We're announcing for the first time here at the festival that in December we delivered two specially built VR cameras to the space station. And yesterday, Felix was in Houston for our very first day of shooting. We got our first shots for the project.
Wow.
So before we dive in and tell you what this is all about, I'm going to have our panelists introduce themselves. I'll introduce myself too. I'm Mia Trams. I'm the very long title, editorial director of Enterprise and Immersive Experiences at Time and co-producing this project.
And Jonathan Woods, executive producer of video at Time. I've been with Time for 7 years and previously produced Year in Space. That's where I got the space bug.
My name is Liz Warren. I was one of those kids that you knew growing up that always wanted to be an astronaut, work in the space program. So for about 25 years, I've been involved with International Space Station development and research projects. And I work for the ISS, International Space Station National Lab. I'm an associate program scientist there. And I'm here to represent this ability to do research and projects such as this on the space station.
And you have a PhD in human space exploration, right?
Right.
I'm Felix Dajanès. I don't have a PhD. I'm a co-founder, creative director of Felix and Paul Studios, and I'm also the director of the ISS Experience.
Awesome. So Felix, why don't you start this off and give our wonderful guests sort of an overview of what the project is.
Right. So, well, you've seen some of it in the teaser, in the trailer. This is a project that is filmed in cinematic virtual reality in which we will take audiences inside and outside of the space station through the immersive and experiential power of virtual reality. So in this project, we're going to look at the research, the science, the work that is done on the International Space Station, and we're also going to look closely at the reality and challenges of learning to live in space and learning to live in space conditions, and we're going to be documenting that. So most of what we will film is going to be captured inside of the space station over a period of about 9 months, but as the story builds up, it's going to gradually ramp up to a spacewalk where we will take audiences outside of the space station alongside the astronauts to capture the first ever cinematic VR spacewalk. And we're pretty excited. So yesterday was our first shot, the result of a very, very long preparation process. And it was extremely emotional to finally get started on this ambitious endeavor, I would say.
Absolutely. Jonathan, if you could also give us a little context on what led up to this project from the Time side and talk about how the two teams came together.
Yeah, so around the late part of 2015, we were wrapping up a year in space. 2016, we were wrapping up a year in space, and our managing editor came and they said, well, what's your next year in space? And I'm like, well, I'm going to take a vacation first. So it took a few weeks off, and we came back, and we started brainstorming, and we thought, like, what hasn't been done before?
Because we like to build these impossible projects for ourselves.
So
really just trying to drive ourselves crazy.
Yeah, mostly. And then figuring out ways to pay for it. But we just said, what's never been done before? And we thought, oh my gosh, let's do a spacewalk in virtual reality. So we called NASA, and they're like, you guys are nuts. But we started in earnest, really, January of 2017, the first conversations with NASA. And for a year, we were working with what was then called the Center for Advancement of Science and Space, CASIS, and to basically get a contract together to get these cameras to space. And figuring out, we're just looking at this mountainous amount of work that had to be done for something that never had been done. We knew what it was like working with NASA and all the things that, you're working with engineers and safety and operations and big budgets, and we're like, this stuff is really scary. Fast forward to January of last year, almost a year ago today, we got a call from one of our friends at NASA who said, you guys might want to be aware that there's another group of people who are working on a similar project. And I was like, let me at them, I will destroy them. I don't like competition, I'm a little bit competitive. And so Sundance last year, Dylan Mathis introduced us to Felix and Paul. So we invited them over to the place we were staying for a meeting, and I would describe this as like dogs getting to know each other, where they're kind of smelling each other and trying to figure out, like, can I trust him? And like there was no stripping of teeth, but we were definitely trying to figure out, like, is this a good fit for the Time brand to work with Felix and Paul? And I mean, you can shed some light on the meeting, but we very quickly found out that, I mean, these guys are a best-in-class shop. They're going to do amazing work. They had a vision and a track record and a technical acumen that we certainly didn't have, and they had an amazing project that they'd already done on the ground, and you should talk just a little bit about that.
Cool. Yeah, I remember that meeting. We didn't know if we liked each other at first.
Yeah, we like each other now, I think.
No, so basically, we also have a backstory that is space-related. So at Felix and Paul Studios, we spent 2 years from 2016 to 2018 producing a virtual reality series called Space Explorers that focuses on the present and future of space exploration. That project was done in collaboration with NASA, SpaceX, Roscosmos, Oculus, Facebook, and it was a pretty ambitious endeavor. A lot of astronauts and cosmonauts participated to it. And as we were doing this, we started to circulate inside of NASA the idea of what we wanted to do next, and that was to send virtual reality cameras to space to be able to do a full production shot on the ISS inside and outside over the course of maybe a year. And they also told us that we were crazy, and they also told us that Time was working on something similar, and that's where our stories connect. We got connected as potential competitors / people who could maybe work together if we could find the right synergy, and we decided to go for the latter option, and here we are 1 year later.
We got the cameras in space.
Yeah, exactly.
Awesome.
Thank you.
So Liz, science is a huge part of this project, both, as what we're showing going on in the space station, the experiments that you all are helping to run, but also, how it relates back to life on Earth and the future of human space exploration. It's the primary concern of your team. Can you talk a bit about the experiments that are currently being done on the space station and the relation to life back on Earth?
Absolutely. So the International Space Station was built over many years. There's been people living there continuously, not the same people, for 20, almost 30 years. And it is a phenomenal laboratory. It's unlike anything else on the planet. And it was designated as a U.S. national laboratory in 2005. And so my organization, the Center for the Advancement of Science and Space, we manage that resource. And essentially, we want to maximize use of the International Space Station. So we ensure that it is open to other government agencies like the NIH and NSF, commercial industry, big companies, Fortune 500, small companies, as well as academia and non-traditional partnerships such as the Time and Felix and Paul relationship. And the science that we're doing on the space station is a huge breadth. It covers biology, biotechnology, some remote sensing, studying the Earth, human research, looking at our own health and how it might help us explore further in space, and understanding some aspects of that help us understand human health here on Earth, and physical sciences as well. And through that, my organization, while NASA focuses on trying to get humans and machines further out into space, safer and more effectively, my organization has a mandate to bring a benefit from space research back down to Earth. So some examples of research that is, one of my favorite examples is something called protein crystal growth. Maybe you've heard of it in the past. And in space, let me back up and say, doing research in space is analogous to looking at your project with a new lens. It enables breakthroughs. It's completely different. Everything we know is in the presence of gravity, right? Every experiment that has ever been done on Earth has this presence of gravity. And if you change that variable, if you remove that variable, it really is eye-opening for scientists and even filmmakers. And so one of my favorite examples, as I mentioned just a moment ago, is protein crystal growth. In space, there's no convection, so candles burn differently, water moves differently, and proteins crystallize differently. And there's a long story behind that, but essentially it might allow us to design better pharmaceuticals, maybe faster and more effective. Merck Industries, pharmaceutical company, big pharmaceutical company, just completed a study on a cancer drug that is on the market right now. It's called Keytruda, and it's actually a cancer drug for a variety of cancers. But you have to go to a physician's office or a clinic and sit for about 4 hours while a very, very thick infusion of Keytruda is put into your body. And Merck was interested in going to the space station to see if they can understand how to formulate the drug a little bit differently so that it can be put into an injection where a patient can do it at home. So that's like one example of using space to bring a benefit back down to Earth.
Yeah, so our hope for this project is that we capture some of the work that is being done on the space station, not just, to wow you by immersing you in it, but to really teach about the importance of the space station as a science lab.
Absolutely.
So approaching storytelling in space, similar to approaching science in space, opens up many different cans of worms and presents many, many different challenges. There's a line that I love in the trailer from astronaut Reed Weissman where he says, everywhere you're going to want to put that camera is exactly where people are not going to want you to put it. So, we've had to do everything from training astronauts to being VR cinematographers, working through months and months of contracts at NASA. We're still trying to bring on partners and sponsors. The cost of doing something like this, is quite at a different scale than what we're used to working with. And, there's endless challenges wrapped around all of this. So can you, Felix and Jonathan, talk a little bit about what are some of the challenges we've cleared? What are the challenges that lay ahead? What are the things that you've had to consider in this particular production that just have never had to happen before?
Well, I can maybe start from the example of what the astronaut talks about in the video, which is camera position. And that's a very vital thing to virtual reality storytelling, is where you actually place the camera. And in our practice at the studio, we like to think of the virtual reality camera as if it was a person. We generally want to place that VR camera where a person could actually physically be or stand, and that's a massive factor in building a sense of immersion for audiences. So we're talking about putting the camera at a place where a human could be with sufficient clearance around the camera so that you feel that your buddy could be there. But that's good on Earth. But when you bring that philosophy on space station, then it brings a lot of problems because the space is not that big on station, and there are some pretty critical operations being done by the astronauts in space with a big camera that can be in the way. And so we run a very thorough topology study with NASA and NanoRacks, our subcontractor, and Felix and Paul Studios to try to identify all the possible places inside the station where we could fit our virtual reality camera to capture the kind of shots we want to capture. So it's a balancing act between our creative desires and the reality of the logistics in space, basically. And then I can talk about downloading gigantic amount of data from space. I could talk about scheduling shots. I mean, everything is complex, but everything is very rewarding at the same time.
I think something that's super interesting is, the astronauts can't just film willy-nilly whenever we want them to. We actually have to schedule time for the astronauts in their daily workflow to film. So we have, I think, 180 hours of filming time. Is that right?
184 hours of task-listed time that NASA has allotted to make sure that we get the coverage that we need, which is an extraordinary gift. And I think, Liz, you know the task list and schedule for NASA, it's a lot of time. I mean, the astronauts were like, that's a lot of time.
That's a lot of time.
Thank you.
Going back to the technical things, there was a moment that I just loved. So we work with this company called NanoRacks, which is responsible for helping us send cameras into space. And I remember our first meeting. We went down there. We were filming the meeting as it was happening. Amid doing this, we're also doing a behind-the-scenes 2D series that we're going to release throughout the mission. So we're basically going to bring you along. We'll give you a URL at the end so you can follow along with the project. But basically, telling the story of how we're actually able to do this, because I think there is a lot of interest in figuring out, you know, what does it actually take to send things to space? What does it take to do the story? So we're at NanoRacks for our first meeting in June of this year, and we bring in a prototype of the camera, and Felix and Paul Studios put a lot of effort into making sure that that camera was pretty much where it needed to be. And Liz, you mentioned convection. So convection doesn't work the same way in space. So they said, well, you know, what's the normal operating temperature of this? And I forget what it was, Celsius. And they're like, well, you're going to have to build a fan rack on top of this because the heat will just collect around the device, and it could get so hot that it could combust. And we're just, I mean, I was sitting there thinking like, oh my gosh, this is so insane. So all these little things, I mean, they've got thousands of people that are supporting life on orbit, and which you guys did a beautiful job of telling in the first iteration of Space Explorers. But that was just one of those where I'm just like, okay, would have never thought of that one. So then how does that impact filming, you know, the zenith, the top, and the nadir? So we need, you know, we set up the camera, we need to invert it, and then it's just this whole, and these guys are pros at it, so I mean, you could make it sound
I think this would be a good opportunity to talk about the cameras. That's a really big part of this project, and you know, the difference between what's on the station now versus what will be sent in a few months.
In this case, what we did is we started from an existing camera called the Z-Cam, and we actually built a custom-made for space motorized rig. So basically we fit the camera inside of that motorized rig, and what this camera does is it performs what we call a slit scan. So it rotates, it's like a little robot that rotates, and it captures a very precise 3D stereoscopy, 360-degree capture of the environment that we're in, which is essential because we're working in very tight spaces. So that gives us the kind of data that we need to reconstruct extremely precise 3D 360 stereoscopy in post-production. And so the astronauts, they receive a list of operations that they need to do in order to calibrate the camera, in order to adjust everything, and they perform that protocol, and they're supervised from Earth, so if there's something that goes wrong, we can tell them and we can course correct the operations. But that's pretty much how it works. So basically the astronauts, they become your cinematographers. They become your crew. They are the soundman, they are the director of photography, they are a proxy for you as a director because they also have sometimes to make decisions. They are the technical team, they are everything, and they need to do all that to deliver a project at a very high production value level. So it's quite an extraordinary collaboration working with them.
I think one other thing about that was really fascinating too, when we figured out how is this actually going to operate, how are we actually going to produce this series, we figured out a way that we can actually monitor the camera and, you know, basically live to tell what the camera is doing from space while we are actually recording. And it's just, I mean, it's amazing to think that, like, you know, your internet at home is pretty good, but in space it's like, you got like, what, 800 megabits per second or something crazy
It's
like that?
suboptimal.
It's suboptimal? Yeah, that was pretty good. But to be able to actually get that image is just a little bit mind-blowing when you're sitting in Houston, Texas at NASA and, like, you know, watching these images come down from space and, oh my gosh, it's actually working.
I used to watch, you know, those films about space where every time that they succeed in doing something, people in mission control, they throw like sheets of paper, and I used to think that they overdo it, you know, when I was a kid watching these films. It can't be that satisfying, but then the first time you like get your shot and it records, you're like, yeah, and then you go through the data and you just surrender to the emotion of this because it's so incredible, it's so complex to do.
We're very excited, of course, to enable such a project. And yeah, the complexities, we've just kind of touched the very edges of how difficult a project like this is. You mentioned the convection. Yeah, a camera won't cool the way that it cools on Earth. So you had to come up with a new way of doing that and a new way of stabilizing the camera. And another really cool aspect that you mentioned is the buy-in of the crew. They're excited about this because, you know, I think they are excited to share space with all of us.
Absolutely.
Yeah, you were talking about that earlier when we met. You know, this idea that what they experience up there, only a few hundred people ever in history will experience. So can you speak a little bit more about what it means to be able to share that back to people on Earth?
Well, sure. I think, you know, a lot of us have thought maybe about going to space or what that would be like. And I spend a portion of every single one of my days looking at the imagery that's coming down from space station and looking at pictures of science and looking at the research. And I've always wanted, you know, to go to space. And, you know, there's no more immersive way of feeling like you were there with the crew than this virtual reality technology. There's 3D versions, there's video, but to actually feel like you're there, I think that's really exciting to NASA. It's very exciting to the ISS National Lab and the astronauts. They struggle to share the experience. That's why they take so many pictures, and they're on Twitter, and they're trying to share the experience with those of us on the ground, because the great voyage, the great exploration is something that's in all of us, right? It's in our DNA to explore. And going to space is something that at this point only a few hundred people are going to be able to do. The future is going to be changing. More of us will be able to go, but for right now, for those of us in this room, probably this is as close as we're going to get, including myself. And I'm excited about that, and I know that the astronauts are very, very excited about that too. They can't bring their families to space. If you ask most astronauts, they all want to go to space again, and if you say, well, what would you change? They say, I wish I could bring my family. And maybe this will be a way that they can sit around the space dining room table with each other and their family, and that's the way that this will be shared for all eternity.
That's a long time. That's a good goal for us. All eternity.
For a pretty long time.
One more question around production, Felix. We've jumped a lot of hurdles to get here. What are the things coming up that you're looking at that you're trying to plan through, and the logistics we have to clear?
So basically, you can't really improvise when you shoot in space. So everything needs to be planned ahead of time. And so we're working on building a shot list about like a month ahead or a couple of weeks ahead. And we're trying to identifying the kind of science that we want to capture, the kind of human moments, human interaction moments between the astronauts that we want to capture, the meals, the physical training, the exercise, and all of that, preparation for a spacewalk, docking operation. There's just so many activities going on in space. And so the proper planning of all these things to use those hours that you mentioned in a very wise way, in a very efficient way, is a big part of what we're doing now at this moment in time where the camera is now operational in space. So that was like the first big milestone, and now the next milestone is really focusing on the creative and being able to capture the right footage, basically, to tell the story that we want to tell. So that's where we are at right now.
Yeah, and I think it bears mentioning, this is the International Space Station. We are working with NASA, but we're also working with astronauts from across the globe. So that does add a layer of complexity, right?
It does, and so you need to get basically the approvals of Roscosmos and of the ESA and JAXA, and so it's an international partnership, and so everyone needs to be on board and agree on making this international project, basically. So that is something that we're getting at the end of in terms of getting all those green lights.
Yeah, lots of paperwork. This project, in addition to being a VR series, has some other components to it that we're all really excited about, and it spans technologies. We're looking at a new kind of distribution for this. Do you guys want to talk a little bit about how does this make its way out to the world when it's all produced?
I can start, and maybe you can comment on that. So it's a virtual reality project, first and foremost, but it's also going to be outputted as an augmented reality project, and it's also going to be distributed as an installation that will travel all across the world in air and space museums, as well as in schools. So we're building a pretty ambitious online and on-site distribution plan for this project so that as many people as possible, regardless of ages across the planet, will have the opportunity to experience this.
Yeah, and then I would just reiterate, we're going to be following this every step of the way, because as we start to do some of these historic firsts, first cinematic spacewalk and virtual reality, you can guarantee we're going to have cameras in Mission Control Houston watching as those astronauts prepare for their spacewalk and go out the hatch. And I think that that series will live on not only in Time for Kids and through the educational materials that we're distributing nationwide with the Time for Kids platform, but also across time and its own operating development social properties as well.
And this is a question for all of you, but I'm going to start with Liz. The space station wasn't supposed to still be in orbit, right? It was supposed to be decommissioned at a certain point, or maybe you can correct me here. But there is a significance to doing this project now, and could you talk a little bit about that?
Well, absolutely. So we have this incredible laboratory, like I mentioned, in space, and it's there right now, and it is humankind's as an international community, as a globe, it's really been an incredible stepping stone. And NASA and the international partnership, we're going to explore further, but we are learning lessons on the space station right now, such as how to keep life support systems working. You don't want to find out halfway to Mars that your oxygen generation system's kind of wonky. We have to learn these lessons now. And the human aspect, living in space, while it looks like a lot of fun to float, it's not really all that great for the human body. And a lot of changes happen, and that's why you'll see exercise about 2 hours a day. Astronauts will be working on keeping up their bone mass and muscle mass and cardiovascular health. This is a stepping stone to, we have to use the space station in order to go farther. And documenting this now is really important. The space station isn't always going to be around. We certainly hope to use it as a laboratory for many years. Approved through 2024, and we're hoping with the international partnership that will go through 2028 and maybe even further. But this has been, in my opinion, and there's a little bias, but this is, I think, humankind's greatest achievement. Scott Kelly, who you are very familiar with from the Year in Space, he commonly says, this is the hardest thing that we have ever done, but we're doing it. We have people living in space, they're working in space, they're benefiting us here on Earth. If we can do that, there's nothing we can't do. So I think it'll serve as a lesson for the future. And if we're all able to go to space and see what was it like on the space station, I think that will be something that it really is a great documentation. It's a great thing to have, and this is really a golden age of space. This is pretty great.
And I would dovetail off of your remarks just to say, like, 2019 is going to be an incredibly important year for space. We're right on the cusp of seeing the first commercial launches from SpaceX and Boeing, who have done an incredible amount of innovation, spending billions of dollars, some taxpayer money, some of their own money, to try and find ways to land first stages of rockets on the ground again. And I think it's been so cool to see little bits and pieces of this. I think from Time's perspective, it's been very important for us to find an important way, a meaningful way to chronicle this moment in time for historical perspectives, and so that we can actually look back and say, wow, remember we did this space station, and now, like, imagine where we're going to be 20 years from now. And it's so cool to think about all the innovation that's happening, and I think this hopefully will chronicle a small chapter of our time off the planet.
Right, well said. I think in our perspective, we from the beginning have looked at the International Space Station as the first step in what we consider to be mankind's inevitable expansion into space at some point. And so in this project, I hope we're able to look at what we've learned over the past 20 years working and living on the space station, what we continue to learn about living in space today, in the perspective of the next steps in the history of human space flight, so long duration flight, going to Mars, deep space exploration, and all that. And hopefully that project will be a good milestone in documenting space exploration in that direction.
Absolutely. Liz, you've talked to us a little bit about the ways in which exploration is endemic to human nature, and I'm sure that had a lot to do with why you chose to study it. Can you just share with us, some of your thoughts on the importance of exploration to humanity, and what parts of that might come through in this work that we're about to embark on?
I think a really key aspect is, I said it earlier, but it's written in our DNA to explore. We're curious beings. It's really, I wanted to be a scientist even before I knew I was going to be a scientist, before I even liked space, because I was also one of those kids who was like, why is the sky blue? Why does the water look like that? Why is this happening? And I never stopped. No one ever, no teacher ever kind of beat that out of me. I keep asking a lot of questions. And that's really endemic to us as a species, and that's so good because it keeps us learning, it keeps us advancing. And the space program, we started exploring in small ships, and then our ships got bigger, and we brought more knowledge back, and now we're doing this in space. And I think that it's who we are as a species, and it's critical that we do this. It keeps us learning, it keeps us advancing as a society. And the International Space Station is a truly great example of this. And telling that story as humans. We're all going to be there together on the space station in this virtual reality world, and I think there's no better way to share that experience than through what Felix and Paul and Time are going to do here. We're all going to be there in space together. And I'm really excited. I cannot wait to get to there.
Us too.
There you have it. Thanks for joining us on this episode of Larry Talks. Special thanks to Time Video, Paul and Felix Studios, NASA, and SpaceX Communications Director James Gleason. Until next time, see you at the movies.